and in today's video, we are gonna go over the ideal gas law. What is this? Something about chemistry, I guess. Never learned this equation, but okay. So you can see a box and there's gases here. We need to define the four variables of a gas. Convert between various pressure units and use Kelvin, solve for missing oh, it's this equation. I've been at peace with Jerry for whatever topic he gives me. Like, I think I realize it's just not that deep. Defines standard temperature pressure conditions. STP. I forgot what that stands for, but we'll learn it. Okay, so the four gas variables we have to describe a gas is pressure, which is the force exerted over an area, the volume, the space the gas occupies, moles, the amount of gas particles in the actual box or whatever, and temperature, average kinetic energy. And if we know three of the four, we can always find the fourth, but if we only know two, better luck next time. Okay, so the pressure units we need to know is atmospheric, which is ATM, milliliters of mercury, or mmHg, or torr, and kilopascals, kPa. That's like the atmospheric pressure, kPa, I think, and pounds per square inch, psi, that's the pressure. Okay, so Kelvin, in order to find Kelvin using Celsius, you take whatever Celsius temperature you have and you add 273.15. And if you ever get to 0 Kelvin, that's like it's called absolute zero, and that's where no molecules are moving at all. And scientists have gotten really close to absolute zero, but it is basically almost impossible to get there. Why don't they just try stick it in a piece, stick it in a freezer, just leave it there a couple years. It's kind of cold in there. Okay, the ideal gas law equation is P times V equals N times R times T. And P is pressure, V is volume, N is amount, and T is temperature, and R is the universal gas constant. Hold on. Oh, I thought I was about to sneeze. But okay, so the gas constant depends entirely on the units used for pressure. And if the units don't match R, your answer will be wrong. So without case 1, pressure isn't ATM. There's multiple ways to describe pressure. But our second case is kPa, right? And usually 0.0821 is the most common value used on an AP exam. Yeah. So it has to match R has to match whatever pressure unit you're using. If my voice sounds different, I don't know. I think I'm a little sick. But standard temp and pressure. Oh, I was right. But this is a baseline condition, and it allows us to make comparisons more easily. Like standard temperature is 0 degrees Celsius or Kelvin, or standard pressure is 1 atm or 101.3 kPa. And at standard temp and pressure, 1 mole of ideal gas is 22.4 liters. Hold on, excuse me. And I am back. Oh my god. Okay, so let's do a step-by-step solving strategy. Okay, so we need to list out the unknowns and knowns we have, just like in physics. And we have to convert temperature to Kelvin. So make sure to add the 273.15 from to the Celsius, and then rearrange the formula of P times V is equal to N times R times T to get the variable you want on its own, and then calculate and check for significant figures. I will do a video on significant figures later because I was really bad at significant figures in chemistry when I was in high school. So yeah. Okay, so practice problem 1. Find the pressure. A 2.5 mole sample of neon gas is placed in a 5-liter container at 225 degrees Celsius. What is the pressure inside the container? Pause the video to find out. I will give you a couple minutes. Lovely weather today, I'm not gonna lie. I am not going on my phone, so stop it. Fall to the sky. Okay, okay. So you should have gotten 12.2 ATM. And I'll let you pause the video to look at this step-by-step equation if you need it. But we're gonna keep moving forward. Okay, so we need to find moles this time. So let's say you have an oxygen tank and its volume is 12 liters. The pressure gauge is 1500 mmHg, and the temperature is 300 Kelvin. How many moles of oxygen is in the tank? And if you need a hint, you must convert the 1500 to ATM first, and then you use this equation. I'll give you another couple seconds or minutes. Follows to the sky. Okay, I'm getting distracted. Okay, you should have gotten 0.96 moles of O2, and you can look at the steps. If I got it wrong, let me know. But don't blame me, blame Jerry. I'm just an innocent bystander. Okay, let's move on to what is an ideal gas. So when we say ideal gas, no gas is like perfectly ideal, just like how there's nothing that's at absolute zero, but it's like almost theoretical. And there's I think when uh four things about an ideal gas. So particles have zero volume, no attractive force, no energy loss, I think, when it collides. And another one I think about chemistry, but I think you learned that in high school chemistry. And an ideal gas fails when there's a lot of extremes, like extreme high pressure or extreme low temp. And at those extremes, gases will actually just turn into liquids. Okay, so, oh my god, bro. I don't know why it messes up so bad, but okay, so a gas law is temperatures must be in Kelvin, volume is in liters, pressure units must match your R constant, and significant figures should match given data. And don't forget to convert to Kelvin. And Jerry still has not fixed my slides, so if I get too popular, they're gonna question why my slides are so bad. But it's whatever. It's fine. Okay, so I think that's good for today's video. If you want, if you need more, just let me know. Or don't. I don't know. Jerry reads all your comments. I'll see you next time. Bye.